Hello everyone. In this lecture we will discuss about the complex reaction in liquid phase Cstr. So, the complex reaction discussed in example 8-5. We have already discussed this example 8-5. So, the complex reaction discussed in example 8-5 now take place in liquid phase 2500 dm cube Cstr. The period is equimolar in A and B, with the molar flow rate of component A is equal to 200 mole per minute and the volumetric flow rate is 100 dm cube per minute. The rate constant or K1A is equal to 10 and K2C is equal to 15. Find the concentration of component A, component B, C and D exiting the reactor along with selectivity CD. Exiting selectivity. So, the selectivity is given to us. It is selectivity of component C with respect to component D is equal to concentration of component C which is leaving the Cstr and concentration of component D which is leaving the Cstr. So, there is a Cstr in which A and B. So, this is a Cstr, this is the stirrer. The component A and component B are entering to the Cstr. They react with each other and they give us C plus D. Along with C plus D, there is component A and component D also, along with component C and component D. Now, there are two reactions inside the Cstr. The first reaction is A plus 2B. A plus 2B give us C, and reaction number 2, 2A plus 3C give us D. So, this is reaction number 2. The rate law for reaction number 1 is minus R1A is equal to K1A into CA CB square, and for reaction number 2 R2, the reaction number 2, the rate law can be written as R2C is equal to K2C CA square and CC to the power 3. So, this is elementary rate law. As you can see, this 2 is the stoichiometric coefficient of A and this 3 is the stoichiometric coefficient of C, and 1 is the stoichiometric coefficient of A and 2 is the stoichiometric coefficient of B. So, these two are the elementary rate law are also given in the question. The initial molar flow rate is also given, and the volumetric flow rate and volume, the reactor volume is also given to us. So, we will solve this question for the concentration of component inside the Cstr and for selectivity of component C with respect to component D. So, the first step to solve this type of question is, there are various steps to reach the solution. The first step is, step number 1 is apply mole balance. Apply mole balance on each and every component inside the Cstr. So, for component A, the mole balance is Fa0 minus Fa plus Ra into V is equal to 0. For component B, the mole balance is Fb0 minus Fb plus Rb into V is equal to 0. For component C, Fc0 minus Fc plus Rc into V is equal to 0. For component D, Fd0 minus Fd plus Rd into V is equal to 0. But there are only component A and component B are entering to the reactor, so this cancel. This is 0. Fc0 and Fd0 are 0. Now, we know that there is a relationship between the flow rate and concentration. So, the flow rate is nothing but it is equal to the concentration into the volumetric flow rate. So, we will write this relation. So, it is C0 into V. This is the volumetric flow rate. Remember, for the constant density liquid system, the V0 is equal to V. So the inlet volumetric flow rate is equal to the volumetric flow rate inside the reactor or exiting volumetric flow rate. So minus Cb naught into V plus Ra into V is equal to 0. Cb naught into V minus, so this is for this is Ca, this is Ca, Ca into V, Ca into V plus Ra into, now this is Cb naught into V minus Cb into V plus Rb into V is equal to 0, minus Cc, concentration of component C, into the volumetric flow rate plus Rc into V is equal to 0, minus concentration of component D into volumetric flow rate plus Rd into volume of reactor is equal to D. So these are the mole balance equation for component A, component B, component C and component D inside the Cstr. So this was the step number 1. The step number 2 is the step number 2 is write the net rate law for each component. Net rate law for component A, B, C and component D. So the net rate for component A is, the net rate of formation of component A is equal to, these can be obtained from the reaction, like reaction number 1 was A plus 2B give us C, A plus 2B give us C, and reaction number 2nd was 2A plus 3C give us D, 2A plus 3C give us D. So in reaction number 1 A is consuming, in reaction number B A is also consuming, in reaction number 1 only B is consuming, and in reaction number 1 C is consuming, in reaction number 2 C is also consuming, in reaction number 2 D is consuming. So D is only present in reaction number 2, C is present in these two reaction, B is present in this reaction, and A is present in this and this reaction. So the net rate of component the net rate of component A is R1A plus R2A. So this is the R1A and R2A, this is the capital A for component A. So R1A mean the rate of component A in reaction number 1. This A shows component A and 1 shows the reaction number. So this is the reaction number 2 and component A. Similarly, RB is equal to, RB is present in reaction number 1, so it is the rate of component B in reaction number 1, so R1B. Similarly, the RC, the rate of component C, the rate of formation of component C is equal to rate of formation of component C in reaction number 1 plus the rate of formation of component C in reaction number 2. RD is equal to the rate of formation of component D in reaction number 2. So this is the net rate for RA, RB, RC and RD. These are the net rates for component A, B, C and D. Now this step number 3. Step number 3. Relative rate law for each component. So relative rate, from this equation number 1 we can obtain the relative rate per component, and from equation number 2 we can also get the relative rate. So RA divided by minus 1 is equal to RB divided by minus 2 is equal to RC divided by 1. Similarly, from reaction number 2, RA divided by minus 2 is equal to RC divided by minus 3 is equal to RD divided by 1. but this is reaction number 1, so you can write 1 here, 1 here, and 1 here. This is reaction number 2, write 2 here, write 2 here, 2 and 2. So now relate these rates. So we can relate these rates like step number 4, relate these rates of component, relate rates of components A, B, C and D. So from this relation we can relate R1C is equal to minus R1A, this relation. Similarly, R1B is equal to 2 into R1A, 2 into R1A. Similarly, from this second relation, we can write R2C is equal to 3 divided by 2 into R2A. This relation, or we can say R2A is equal to 2 divided by 3 into R2C. So this relations. We can also write R2D is equal to minus R2A divided by 2. This one. So we can form many relationship from these relative rates. Now step number 4. Write rate law. Write the rate laws. So the rate law for these rate law are given for the elementary reaction, for the two elementary reactions. So it is given to us minus R1A, K1A, CA into CB square. R2A is R2C, this is C component, K2C into CA to the power 2 into CB, CC, sorry, this is CC, CC to the power 3. So these are the rate law. Write the rate law. Step number 4. Now what is step number 5? Step number 5. Combine mole balance. Combine the mole balance with net rates of component A, B, C and D. So combine mole balance with net rates of all components. So net rate of component A is RA, net rate of component B is RB, component C is RC, and net rate of component D is RD. So step number 5. This was step number 5. So the mole balance for component A is, what was the mole balance? It was Ca0 into V minus Ca into V plus Ra into V is equal to 0. For component B, the mole balance was Cb0 into V minus Cb into V plus Rb into V is equal to 0. For component C, Cc, V minus plus Rc into V is equal to 0, and minus Cd into V plus Rd into V is equal to 0. So these were the mole balance, and these are, if you can see that these are the net rate of reactant A, net rate of reactant B, net rate of reactant C, net rate of reactant D, and this net rate RA can be obtained from RA, which is equal to R1A plus R2A, R1A and R2A. This RB is equal to this RB is equal to this is RA. This RB is equal to R1B, because B is present only in reaction number 1. This RC is equal to C is present in two reaction 1 and reaction 2. So R1C plus R2C, and this RD is present in reaction number 2 only. So this is the R2D. So in place of RA we will write these relation. In place of RB we will write this one, in place of RC we will write this one, in place of RD we will write this one. So now from the relative rates we know that R2A is equal to, you can see that what is the value of what is the relationship between R2A and R2. Now this, what is this, the value of this R2A? So the this is R1A and this is R2A. Now the R2A value can be related. So the R2A is equal to 2 divided by 3 R2. This R2A is equal to, from the relative rates we have already obtained that R2A is equal to 2 divided by 3 into RC. 2 divided by 3 and 2 divided by 3 and to R2C. So this one. Now R1B from relative rates, R1B is equal to 2 times R1A. So it is equal to 2 times R1A. R1C, what is the value of R1C? It is equal to 2 times R1A. 2 times R1A. So 2 times R1A, and this is R2C, R1A. This is 1, R1A plus R2C, and R2D is equal to the R2D value is equal to minus R2C divided by 3. Now this, the value we can put the, now this, the value of we will put these relationship, this R2A and these relation in these equation, these 4 equation. So we will put these relation in these equation. So now I am putting it. So I am putting it RA. I am further simplifying it. I am further simplifying that RA is equal to R1A, 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 R1A plus R2A, but R2A is equal to 2 divided by 3, so it is 2 divided by 3 R2C. Similarly, RB is equal to R1B, but R1B is equal to 2 R1A. RC is equal to R1C, but R1C is equal to 2 R1A and R2C. And RD is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RC is equal to R2C, but R2C is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RD is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RC is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RC is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RC is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RC is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. And RC is equal to R2D, but R2D is equal to 2 R1A and R2C. And RD is equal to R1B, but R1B is equal to 2 R1A and R2C. but R2D is equal to minus R2C divided by 3. So these are the net rates for components. Now we will put these value for RA. We will write this value in this equation, back in this equation in this place, and for RB we will put this relation in this place. For RC we will put this relation in this place. For RD we will put this relation in this place, and we will further simplify that the relationship between R1A and concentration is equal to K1A into CA into CB square, and the relationship between the R2C and concentration is equal to K2C CA square CC cube. So now in all these equations there is only R1A and there are two terms. The one term is R1A, you can see here and here, and the second term is R2C. So from R1A we will in place of R1A we will write this relation, which is the rate law relation, and in place of R2C we will write this relation. And after putting these relation in place of R1A, R2C, we will put the in place of R1A we will write this relation, in place of R2C we will write this relation in the above equation, in these equation, and we will further simplify it in polymath. So we will obtain a relationship between concentration of A, concentration of B, concentration of C, and concentration of D. We will find the relationship, we will find the concentration of A, CB, CC, and CD in Cstr, and selectivity of component C with respect to component D in the Cstr is Cc divided by Cd, concentration of component C and concentration of component D from this relationship. So in the coming lecture we will use polymath to solve this problem. So thank you very much for your attention. If you are new to the channel, please like and subscribe.